Oh, yes, we are. Okay, so we're going to start on question number 26. And 26 is a little bit different. It's a little different, okay? All right, so they give you y equals, what does it say? X minus 1 over x plus 5. X minus 1 over x, did I say plus 5 or minus 5? X plus 5, okay. All right, so they want a graph here. What's different about this is you have an x on top and an x on bottom, okay? An x on top and an x on bottom. So this makes it a little bit tougher, okay? First off, you need to find your vertical asymptote. Your vertical asymptote, remember from the video, or if you didn't watch the video, I'll tell you right now, it's what makes the bottom 0. What could I plug in for x to make the bottom 0? Negative 5. So at negative 5, back here, 1, 2, 3, 4, 5, we draw our vertical asymptote. That's our boundary, okay? Now for a horizontal asymptote, what you need to do is you take the lead coefficient here, which is a 1, divide by the lead coefficient here, which is a 1. 1 over 1, which is 1. So our horizontal asymptote is at 1. So we go up 1 and draw our horizontal asymptote. Now here's where it gets tricky, okay? You might be tempted to say, well, okay, he was saying in the videos that if it's negative, it's the second and fourth quadrants, and if it's positive, it's first and third. And that's what I was saying, okay? Well, this is where it's tricky. Is the top negative? It kind of depends, okay? I mean, if I give you this right here, is the top negative? No, it's positive 10. It's always positive 10 because it's 10. What is it? X, what was it? Minus, what was it?
X minus 1.
X minus 1, okay? Depending on what I plug in for x, the top could be negative or positive. If I plug in 5, the top's positive. 5 minus 1 is 4. If I plug in 10, 10 minus 1 is 9. If I plug in negative 6 minus 1 is negative 7. So it kind of depends. So how do you determine is it the top, is it the first and third or the second and fourth? So here's what you need to do, okay? You need to do this. So it's going to be either first and third or second and fourth. We need to find our y-intercept. Our y-intercept, where it touches the y-axis, okay? So the way you find the y-intercept, you plug in 0 for x. You plug in 0 for x. Plug in it for both x's. So I plug in 0 here. We're going to have 0 minus 1 over 0 plus 5. 0 minus 1 is negative 1. 0 plus 5 is 5. So it's going to hit the y-axis at negative 1/5, okay? Here's our y-axis. Where's it negative 1/5? Well, here's negative 1. So negative 1/5 is going to be right about here. Now, I'm going to give somebody the opportunity to shine, okay? To really impress me. And if you don't answer it, you're going to go, oh, geez, I should have said that. Geez, because it's such an easy, it's okay. I've never told you this yet, okay? But I'm going to give you a whole bunch of information right here, and hopefully you can put it all together and say, well, yeah, it's obviously this then, okay? So our y-intercept is right here. So do you think this graph is going to be in the first and third quadrants or the second and fourth quadrants? Any guesses? And I want to know, you think it's the first and third because, or it's the second and fourth because? And again, if you get it, great. If you don't, you're going to go, oh, shoot, I should be able to answer that, okay? So again, look, you got to be quiet because I already know you have 100%, okay? What do you think? Did she tell you the answer before?
No.
Okay.
The second and third because it's negative.
Well, wait, hang on. First and third, that's not an option. First and third
No.
or second and fourth?
Second and fourth.
Why?
Because it's negative 1/5.
So?
So it's a negative.
You're close. You're on the right track. I'm not saying you have the wrong answer or the right answer. The reason's a little shaky.
Second and fourth.
Why?
Because it's less than 1.
That's kind of like what he was saying, kind of along the same lines. Look at the picture, though. Actually, you don't need to look at any of this. Okay? I'm going to give you a huge clue right here.
Because the point dipped under the.
Huh?
Because the point dipped under the x-axis, and if it's the first and third, the y-intercept point be above the x-axis.
Simpler way of saying that is this. It's going to be in the second and fourth because the dot
It's in the fourth.
is in the fourth. If it was in here, it'd be in the first. That's what the dot is. This graph's got to go through this dot. If it's in the first and third, what's the problem with that? It doesn't hit the dot. It's got to hit the dot. Okay? So it goes like this. And, oops, hit the dot. Okay, let's get rid of the other one. All right, so that's what it looks like. Okay? I really think the hardest part of this assignment is not this part. And the hardest part of the assignment, you don't need to worry about on the test. Because when I do these, I do this, and then I look at the graphs, I'm like, which one is it? It's hard to kind of tell which one it is, okay? And again, I want to point out here, okay? This is what, let's say that this is a test question, and Iobi has this, okay? And Maddie has this. Who's right? You both are. You're both good, okay? So as long as, I mean, the main thing are the asymptotes, and then just make sure you put them in the right spots. Let's try number 27.
What about the domain?
Oh, yep. Thank you. Domain and range. Okay. Okay, domain is everything except, okay, so domain, look at it left and right. It hits everything except for -5. X can't be -5. Okay? And the range, okay, look at it up and down. It hits everything except for y equals 1. It can't be 1. Okay? Basically, the domain and the range are the asymptotes. Okay?
Why
Whatever the
is it one?
What's that?
Why is it one and not negative? Or 1/5?
Say it one more time.
Why is it one and not 1/5?
Because hang on a second. It's what it can, 1/5. It actually does go through 1/5. The graph goes
Okay.
through -1/5. It doesn't go through +1. Okay. Let me ask you this: does this go up forever?
Yes.
Does it go down forever?
Yeah.
Yes, it does. You think, oh, it hits everything, and no, it doesn't. When it goes up forever, but it never gets to, up here to 1. It never gets to 1. There's an asymptote there, okay? Then it takes off above 1, okay? It's kind of like this. If I was on that side of the room, and I'm walking this way, and I walk half the distance every day, okay? And in Mrs. Allen's room, she's way over on the other side, and she's walking this way. We're like walking towards each other, and we always walk half the distance. We're getting closer and closer and closer, but neither one of us ever get to the wall. We never get there, okay? 27. Okay, x plus 6, 4x minus 8. X plus 6 over 4x, what is it, plus 8? Minus 8. Okay. Okay, so the first thing we need to do is find out what makes the bottom 0. Now, some of you can just look at your head and say, oh, well, this is, and I'll tell you what, I'm not trying to embarrass anybody here, okay? I do not want to embarrass anybody. This is a type of question that you've got to be able to do literally in your head. And what I mean is this. If I give you this right here, 7x minus 3, 2x plus 5, 9x minus 11 equals 0. Okay, and I'm not going to make anybody embarrassed here, but if you can't answer this right now, listen up. This is something you've got to be able to, getting out of this class, there's certain things in this class that are more important than others, okay? I mean, if you can't graph an absolute value function, can you pass this class? Sure, you can. You might have missed some questions way back when. They're V-shaped in case you forgot what that was, but I mean, we haven't talked about those in 8 months, okay? Something like this, you got to be able to answer this, okay? And this is one that you should be able to do in your head. The answers to this, anybody think they can tell me off the top of their head? Hopefully most of you can. I'll give you the first one. Positive 3/7. Okay, what's the next one? It says 2x plus 5. Negative 5 what? Over 2. And how about 9x minus 11? Positive 11. How are you getting these? Opposite over this, opposite over this, opposite over this. You got to be able to do that, okay? That's I'm sorry, that's easy stuff, okay? You might have forgotten it. Hopefully it comes back to you. So, what makes the bottom 0? Take the opposite of this over this. Positive 8 over 4, which is 2. So at positive 2, we have a vertical asymptote. Okay, wherever the bottom is 0, that's where your vertical asymptote is, okay? And then we take the lead coefficient, since these are both first degree, take the lead coefficient here over the lead coefficient here. 1 divided by 4, which is 1/4. Positive 1/4. So up at, here's positive 1, so positive 1/4 is right about there. Okay? Now, is it 1 and 3 or 2 and 4? First response should be, I don't know. I really don't know, because I don't know if the top is positive or negative, okay? So, let's find our y-intercepts. Okay? Y-intercept. Plug in 0 for x. All the x's. If I plug in 0 here, we have 6. If I plug in 0 here, 4 times 0 is 0. Minus 8 is negative 8. Negative 6/8, which is negative 3/4. So it hits the y-axis at negative 3/4. So here's negative 1. So negative 3/4, so that's right about there. Now hopefully you can answer this. We just answered it a minute ago. Okay. Based on just this, is the graph's going to be in the first and the third, or the second and the fourth? It's got to be first and third. Why? Because the dot's what? In the third quadrant. It was going to like this, and like that. Okay? If you didn't catch this, I'll say it again. If you're wondering, why didn't we find the y-intercept on the other ones? The other ones, you just had a number on top, you didn't have x on top, okay? All right, and then they want the domain and range. Okay, so looking at it for domain, left and right, it hits every single x value except for 2. For the range, you look at it up and down, it hits everything except for, what was it, 1/4, is that what it was?
Yeah.
Y couldn't be 1/4. Positive 1/4. Never hit 1/4. Okay, 28. How many are left? 28, 29, 30, 31. Okay, 20, 20. Okay, I'll do maybe 2 more with you guys. What's that?
Like, for this one up here, we use -1 and 5, but for this one, you use the one that you divide to see what y can.
What?
Like for 26,
Yep.
our y was,
It was for the range.
yeah,
Okay, it's what you need to look for are the asymptotes. The asymptote was at 1, and where the 1 came from was take your lead coefficient over lead coefficient. Okay, same thing here. Okay, where did we get 1/4? Lead coefficient over lead coefficient, 1/4. Okay, so again, think of it this way: domain. You might want to put this down. For the domain, it's the vertical asymptote. For the range, it's the horizontal asymptote. All right, maybe do 2 more, then I'll let you guys work on these. 28. I don't think any more of these any more difficult or harder than the others. I'll do 28, and then maybe I'll tell you what. I lied. I'll do 31 and 32. I think they look a little different. They're really not. So we'll do 31 and 32. All right. So what's 31? So y equals -5x over. What? -2x minus 3. -2x minus 3. Okay, so our vertical asymptote is what makes the bottom 0. We just talked about that. You take the opposite of this, divide by that. So the opposite of -3, so I'm going to put VA, vertical asymptote, is +3 over -2, which is -1.5. Okay? So at -1.5, here's -1, here's -2. So I'll tell you what, before I do the rest of this, what is my domain? Everything except for what? X can't be -1.5. I'm gonna leave it as -3/2. I don't know if the computer distinguishes between them or not, but I'm gonna say it can't be -3/2, okay? The horizontal asymptote, again, since you have x on top, x on bottom, you take the lead coefficient divided by the lead coefficient. So for horizontal asymptote, -5 over -2. A negative over negative is a positive. 5 divided by 2 is 2.5. So a horizontal asymptote is at +1 to 2.5. So what's the range? Everything except for, I'm going to leave it as 5/2. I don't, again, it might take 2.5, I don't know. What do you write on the test, 2.5 or 5/2?
2.5.
On a written test, which one do I want?
Either.
doesn't matter.
I don't care. I really don't care, okay? I'll take either one. Okay, so is it first and third or second and fourth? I don't know. I swear to God, I do not know yet, okay? I do not know. So let's find our y-intercept. The way we find our y-intercept, we plug in 0 for all the x's. If I plug in 0, -5 times 0 is 0. Plug in 0 here, -2 times 0 is 0. -3 is -3. The y-intercept is 0. So it's right here.
What about the,
Say it again.
never mind.
You should.
Didn't you say we can never get 0 though? We can never hit 0.
What do you mean?
Like with our line, when we draw a graph, you said it will never touch 0, like the line.
It never gets to the asymptotes.
Okay.
It can go through when the asymptotes were the axes, but they're moving now. Okay, they're moving up, they're moving left. So yeah. Okay, so where are we? 1 and 3 or 2 and 4?
1 and 3. Or no, 2 and 4.
Why?
Because it's in the fourth.
Right, the dot's in the fourth quadrant. It's got to go like this. And again, I want to make sure it's not that I want to get you on test day, but you got to don't be too sloppy, okay? What if you do this? Is this okay? No. What's wrong with that?
You
It's
just
going through the asymptotes. You can't do that. How about this? Is this good? that good? Almost good, but yeah, it doesn't curve back on itself, okay? One more. Is that okay?
No.
Why? What's wrong with that function?
Not curved, it's always curved.
Listen very carefully as a keyword. You're not wrong, but there's a better answer. What's wrong with drawing that function? It's not a function. Why? What test does it fail? Vertical line test. Okay. Or how about this? What if I have curvature like this? That cool?
No.
What's going to happen? What do those arrows mean? It's going to hit those asymptotes. No, it can't go like that. It's got to go like this. Okay, something like that. Okay, it doesn't have to be perfect, but just something like that. Okay, we good? Okay, so I think this assignment is due tomorrow, but I will tell you that I really think that you guys should be able to knock this thing out. And I'll still have it due tomorrow, but we're very likely going to start a new section tomorrow. Okay, so you're not going to have a whole lot of time, if any time, to work on it tomorrow. Okay, all right, let's get at it.